Early in my career, I spent a year at the University of Michigan as a visitor in a laboratory that studied hypnosis. Casting about for a useful topic of research, I found an article in Scientific American in which the psychologist Eckhard Hess described the pupil of the eye as a window to the soul. I reread it recently and again found it inspiring. It begins with Hess reporting that his wife had noticed his pupils widening as he watched beautiful nature pictures, and it ends with two striking pictures of the same good-looking woman who somehow appears much more attractive in one than in the other. There is only one difference. The pupils of the eyes appear dilated in the attractive picture and constricted in the other. Hess also wrote of belladonna, a pupil-dilating substance that was used as a cosmetic, and of bizarre shoppers who wear dark glasses in order to hide their level of interest from merchants. One of Hess's findings especially captured my attention. He had noticed that the pupils are sensitive indicators of mental effort. They dilate substantially when people multiply two-digit numbers, and they dilate more if the problems are hard than if they are easy. His observations indicated that the response to mental effort is distinct from emotional arousal. Hess's work did not have much to do with hypnosis, but I concluded that the idea of a visible indication of mental effort had promise as a research topic. A graduate student in the lab, Jackson Beatty, shared my enthusiasm, and we got to work. Beatty and I developed a setup similar to an optician's examination room, in which the experimental participant leaned her head on a chin and forehead rest and stared at a camera while listening to pre-recorded information and answering questions on the recorded beats of a metronome. The beats triggered an infrared flash every second, causing a picture to be taken. At the end of each experimental session, we would rush to have the film developed, project the images of the pupil on a screen, and go to work with a ruler. The method was a perfect fit for young and impatient researchers. We knew our results almost immediately, and they always told a clear story. Beatty and I focused on paced tasks, such as Add 1, in which we knew precisely what was on the subject's mind at any time. We recorded strings of digits on beats of the metronome and instructed the subject to repeat or transform the digits one by one, maintaining the same rhythm. We soon discovered that the size of the pupil varied second by second, reflecting the changing demands of the task. The shape of the response was an inverted V. As you experienced it, if you tried Add 1 or Add 3, effort builds up with every added digit that you hear, reaches an almost intolerable peak as you rush to produce a transformed string during and immediately after the pause, and relaxes gradually as you unload your short-term memory. The pupil data corresponded precisely to subjective experience. Longer strings reliably caused larger dilations. The transformation task compounded the effort, and the peak of pupil size coincided with maximum effort. Add 1 with 4 digits caused a larger dilation than the task of holding 7 digits for immediate recall. Add 3, which is much more difficult, is the most demanding that I ever observed. In the first 5 seconds, the pupil dilates by about 50% of its original area, and heart rate increases by about 7 beats per minute. This is as hard as people can work. They give up if more is asked of them. When we exposed our subjects to more digits than they could remember, their pupils stopped dilating or actually shrank. We worked for some months in a spacious basement suite in which we had set up a closed-circuit system that projected an image of the subject's pupil on a screen in the corridor. We also could hear what was happening in the laboratory. The diameter of the projected pupil was about a foot. Watching it dilate and contract when the participant was at work was a fascinating sight, quite an attraction for visitors in our lab. We amused ourselves and impressed our guests by our ability to divine when the participant gave up on a task. During a mental multiplication, the pupil normally dilated to a large size within a few seconds and stayed large as long as the individual kept working on the problem. It contracted immediately when she found a solution or gave up. As we watched from the corridor, we would sometimes surprise both the owner of the pupil and our guests by asking, "Why did you stop working just now?" The answer from inside the lab was often, "How did you know?" To which we would reply, "We have a window to your soul." As we watched from the corridor, we would sometimes surprise both the owner of the pupil and our guests by asking, "Why did you stop working just now?" The answer from inside the lab was often, "How did you know?" To which we would reply, "We have a window to your soul."